Good afternoon, students. Today we'll introduce signal encoding techniques. Before the midterm exam, we spent some time on signals, how to represent data as communication signals. We spent some time in transmission media, some examples of wired media, some of the concepts when we use wireless media like antennas, antenna gain, path loss, and those relationships that allows us to determine distance and received power and so on. So today we will see signal encoding techniques, how to encode the data into signals. We have our data, so we need to transmit as a signal. So what are the mappings from that data into a signal, or what are the techniques for encoding those signals? We will see in this chapter. So we will see how the different ways in which we take our data that we want to communicate and encode it as a signal. So up until now we use simple examples like if any data is a sequence of bits, that is zeros and ones, so we send it. If we have a bit 1, we send it as a high signal, or when you get a bit 0, we send it a low signal. So that is a signal encoding scheme, the common encoding scheme that we use in classes and in exercise book or textbook. So it's a way to generate a signal based upon the data we want to communicate. But there are others, so we will see different encoding schemes like non-return to zero level, non-return to zero inverted, bipolar AMI, zero ternary, Manchester encoding, and differential Manchester encoding. So we will see that one. So we have 4 groups as you see in this one. So we have, so the data is divided into 2, digital data and analog data, and we have digital signals and as well as analog signals. So when we say digital data, it is anything made up of zeros and ones. So example is text files, images that are encoded in binary. And when we say analog data, it's like audio, video, or other measured data that is a continuously varying data over time. So when you say digital, it is a discrete values digital signal, or when you say analog signal, is a continuously varying signal. So depending on the data we want to communicate, we use different schemes in the signal that we transmit this data, with which also distinguished between analog and digital signals. So we have 4 groups: digital data, digital signals, digital data, analog signals, analog data, digital signals, and analog data, analog signals. So we have 2 types of data and 2 types of signals. So the data is encoded into analog and digital signals. So digital signal means will be a discrete pulse of some power level, typically some discrete voltage pulse. So we send some voltage, say plus 1 volt for some period of time, that is a high level, and then for some period of time, let's say minus 1 volt, and we use it for a low level. So this is what you call a digital signal. That means it is a discrete voltage pulse. When you consider an analog signal, it is one which is continuously varying over time. And how do you change the shape of this analog signal? So we discussed in signals, the first chapter, in sinusoid, sine wave. We have 3 basic components of analog signal, that is amplitude, frequency, and phase. So by varying this amplitude, frequency, and phase, we will send as a signal. So we will see that one in the upcoming slides. So when we have digital data, we just have a pulse, one level or another level, but with analog signals, you think of as a sine wave with 3 components: amplitude, frequency, and phase. So we change that one, then we will get the encoding. So this is general about signal encoding techniques. So digital signaling, it is sending our digital or analog data into a digital signal form, and we have analog signaling. We use that we send our digital or analog data as analog form. So let's see the picture. So on this slide, it's a digital signal. So the middle component is a digital signal. So is what we send across the communication medium. So we start from some data, digital or analog data, then analog digital, then we encode that data into a digital signal, which is a sequence of pulses. We send that digital signal across our communication system. The receiver has a decoder that takes all the received pulses, the different levels, and converts them back to analog or digital data. That is when we use digital signaling to communicate our data, irrespective of the type of data. We encode it into a signal and decode it at the receiver. So this diagram is the plot. There is an example of digital signal. So the other approach we use is analog signal. That's a plot in the frequency domain. This analog signal. Here we take our data, digital or analog, and modify some continuously varying signal to transmit the between the transmitter and receiver, and the way we modify is what we call modulation. We take analog signal and we modify either the frequency, amplitude or phase of that analog signal according to what the data is. So this process is called modulation. So the device is called modulator. So as a transmitter, we take our data and use a modulator. We send an analog signal, and as the receiver we take the input analog signal, and as the receiver we take the input analog signal and convert into the data. And this process is called demodulation. So a device that does both modulation and demodulation is called a modem, like your ADSL modem. So it takes data as an input and generates analog signal as an output and send across the telephone network, the telephone line. And receiving modem receives that analog signal and converts back to data.